Greetings, math fans. All right, so this is chapter 2, day 1, and today what we're going to do is we're going to talk about something called trig functions of acute angles. Okay, so last chapter we talked about all the quadrantals, right? Everything with 90 degrees, and now we're going to kind of break off into some special angles, and they're acute angles, and of course, acute angles being less than 90 degrees. All right? All right, so let's just kind of set a couple things up here. If I draw a nice little diagram here, and we call this theta, and of course, this is a nice right triangle, and you guys probably remember this from geometry, right? This is your opposite side. This is your adjacent side. And this is your hypotenuse. Okay? Of course, the hypotenuse being across from the right angle, right? And you guys remember, I'm sure you remember that, SOHCAHTOA, right? And that's how you actually had to use sine and cosine and tangent to figure out different sides or angles of a right triangle. And so we're going to use that right now. And let's take a look at that. So sine of theta, right, is opposite over hypotenuse. Or we're just going to use those letters there, right? Just the O, H, and A. And then cosine of theta is equal to adjacent over hypotenuse. And then we have tangent of theta is equal to opposite over adjacent. Okay? And the reciprocal functions are easy. You just flip it over. So it's H over O. And then we have secant of theta equals H over A. And cotangent of theta is equal to adjacent over opposite. Okay? And truly, I just remember sine, cosine, tangent. I just remember SOHCAHTOA as opposed to trying to remember the other ones. There are lots of clever ways you can remember these, right? You can say sine of theta. It's the surprise trig functions. Oh, the OH, and then the cosine of theta. That's the intelligent, I understand trig function. And the tangent of theta. I don't really have anything for that. I don't know, some animal maybe. And then you have cosecant, of course, that's the Santa Claus trig function, the ho ho ho. And we have secant of theta, which is the comedian's function, which is ha. And then the cotangent of theta, which is the werewolf function. Ow! Okay? You don't really need to remember it that way, but I like just SOHCAHTOA. It works out pretty well. So anyway, that is really important to actually remember that. We're going to be using this a lot with some of the applications and even start trying to put some of the stuff together here with some of the special angles. So let's work with a triangle here. Here's an example. Draw a nice little triangle, right triangle. And I want you guys to, really, we're going to have two columns here, guys. So I want you to write it in two columns. This is be triangle A, B, and C. And this is going to be 5, 12, and what's the other side? 13, okay? And so, again, just write exactly the way I have it in two columns here. So we have sine of A is, we're just going to use SOHCAHTOA, right? It's going to be opposite over hypotenuse. So 12 over 13. Okay? And then cosine of A is adjacent over hypotenuse, so 5 over 13. Tangent of A is opposite over adjacent, so 12/5. And then let's do our reciprocal functions. And I'm doing it in a particular order because you'll see in a second here, okay? So cotangent of A, just going to flip these over, so 5/12, right? Pretty easy. And then cosecant of A is going to be 13/12. And secant of A is 13/5. Okay, pretty easy. Now, the next column, let's do values of B, okay, in a particular order. So I'm going to do cosine of B again using SOHCAHTOA. So we have cosine being, of course, adjacent over hypotenuse, so it's 12/13. Sine of b. And the first one, cosine of b, that's one of my favorite comedians, Bill Cosby. Yeah, I love that one. And then this one is the Lion King's trig function, Simba, 5/13. And then cotangent of b is 12/5. And tangent of b is 5/12. Again, just reciprocal. Secant of b is 13/12. And cosecant of b is 13/5. Okay? So I did it in a particular order because if you notice, if you kind of match things up, right, these are the same values going across. Okay? And so we can say same values across. So what do you notice, or what can you guys tell me about angles A and B? Well, you should be able to tell me angles A and angle B are complementary. Right, they're complementary because it's a right angle, right triangle. That means the other two angles, of course, have to equal 90. That's what you can tell me. The other two angles are complementary, which means they add up to 90 degrees, right? Okay, so basically, if you understand, sine of A is the same as cosine of B. As long as A plus B is 90, that means sine of one angle is equal to cosine of its complement. It's the same value. Okay, so we can say that, let me write this out here, sine of A equals cosine of B, right? And these are going to be something special we're going to talk about in a second. Cosecant of A equals secant of B, and tangent of A equals cotangent of B. So we say these groups of trig functions are called, so these are called co-functions. That's a really important word. You want to put 10,000 stars around that because that is really, really important. So sine and cosine are co-functions, secant and cosecant are co-functions, and tangent and cotangent are co-functions. Okay, very, very important. So let's do a couple examples here. Knowing that's the case, I can say, if I said sine of 20 degrees, sine of 20 degrees is equal to what? Cosine, because they're co-functions, and remember these angles have to add up to 90, so it's cosine of 70. Okay? How about cosecant of 1 degree? What's that equal to? Well, cosecant and secant are co-functions, and so 1 from 90, because they have to be complementary, which is 89 degrees. Okay? So understand that we're not talking about reciprocal functions. These are not reciprocal functions. I can't stress that enough. Okay? If I ask you to write it in terms of a co-function, then make sure you put sine and cosine together. Because what's the reciprocal of sine? Okay, the reciprocal of sine is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. The nice thing, tangent and cotangent are both co-functions and reciprocal functions. Okay? But don't get that mixed up. This is like number one mistake. I ask you guys always to write that down. Number one mistake is to confuse co-functions with reciprocal functions. Okay, it's really easy. Like I'll ask a question, hey, write in terms of co-function. I'll say tangent of 20 degrees is equal to, and people will write cotangent. They'll do like cotangent. Well, this is really bad. Cotangent of 1 over 20 degrees. That's like really horrible. Okay, that's really bad. And of course, being tangent, cotangent, they're kind of nice because you can say tangent of 20 degrees equals 1 over cotangent of 20. Now that's correct, but that's not a co-function. It's a reciprocal function. Okay. Now, obviously, the common mistake is I say sine of 20 degrees equals what, and people go, they don't, all right, I'll even write cosine of something, and they'll do like 1 over 20, or they'll write cosecant of 20, and that's not correct. That is wrong. Okay, sine and cosecant are not cofunctions, they are reciprocal functions. You would actually, if I would say reciprocal, you do 1 over sine of theta, or sorry, 1 over cosecant of 20 degrees. That would be good, but not as a cofunction. Okay, so remember, sine and cosine, secant and cosecant, tangent and cotangent. Those are your reciprocal functions, or your cofunctions. I just said that. Don't write it down. They are your cofunctions. Okay, cofunctions, very, very, very important. So here, let me give you an equation to solve for. If I said solve, and cosine of theta plus 10 is equal to sine of 2 theta plus 20. Okay, so remember, those angles have to be equal to 90, so what you need to do is theta plus 10 plus 2 theta plus 20 equals 90. The most common mistake is to set those equal to each other, but you don't want to set them equal to each other. They're not equal. At 45 they are, but nothing else. Okay, so if I solve this, I get 3 theta plus 30 equals 90, so 3 theta equals 60. So theta is equal to 20 degrees. Okay? Very, very, very important. One other problem is if I, let me just clear this out here. If I tell you the sine of theta minus 30 equals, and I say, well, of course, what's the cofunction of that? And I say, well, you're going to say it's going to be cosine of blank. Okay? If you're given a problem like that, the way you solve it is 90 minus that value. Just like if I told you a sine of 20 degrees, wouldn't you say, oh, 90 minus 20, oh, it's 70? So you say 90 minus theta minus 30. Okay? Please do not leave it in that form. If you leave it in that form, I will actually take a point off because you have not simplified it. You need to do 90 minus theta, so you're distributing the negative, plus 30. So I would get 120 minus theta, and that's what you put there, 120 minus theta. Okay? You could test it. Test it with a value. How about when theta is equal to 50 degrees? Well, if I put that in there, is that going to be 50 minus 30 is 20? Right? And what should this be? Well, 50 or 120 minus 50 is 70. Perfect. 20 and 70 are complementary. Okay? So very, very important that you guys know what you're doing with cofunctions. Okay, so let's talk about special right triangles now. Very special. So special right triangles. Okay? You guys have seen these before. And they are, that's a bad right triangle, but it's okay. It's a 45, 45, 90 triangle. Okay? And if it's 45, 45, 90 triangle, do you remember what the sides are? If you remember, it's x, x, and x root 2. Okay? But I'm just going to make x 1. Okay? Just to make it easier. I mean, because when we deal with ratios, the x's are going to cancel out, and you're not really going to need to know that it's 1, or that it's x. So 1, 1, and root 2, and then you also had 30, 60, 90, and you remember it was x root 3 and 2x. So remember, across from 30 was your x, so that's just 1. Across from 60 was the x root 3, so it's just root 3, and across from the 90 is going to be 2. All right, those are really important triangles to know. Really, really, really important triangles to know. Good way to remember these is people always get messed up with the 60, but I always say people born in the 60s are radical. So that one gets the root 3. Okay? And then even like the root 2 versus the root 3, remember this has got 3 different angles. It's got a 30 and a 60 and a 90, so that gets the root 3. The other one's got only 2 different angles, a 45 and a 90. That one gets the root 2. And also, just logically, remember, as the side gets bigger, so does the angle, right? Think about it. As if you get the angle increases, doesn't the side opposite also get bigger and bigger and bigger and bigger? So that's why you look at the 30 degrees, it gets the 1, and then it gets bigger. 60 degrees, it gets the root 3. That's a little bit bigger, not quite more. It's bigger than 1, but less than 4, with a square root of 4, right? Less than 2. And then the 90 gets the biggest side, so that's the 2. Same thing with the 45, 90. It's 1 gets the 45 gets the 1, and then the 90 degree angle gets the 1 bigger, the root 2, which is bigger than 1. Okay? So what we're going to do is we're going to use these triangles, and we're going to come up with I'm going to have 7 columns. You want to leave a little bit of room here, math fans. You want to, I'm going to cursor down just a little bit here, and I'm going to write down degrees, and I'm going to do sine, cosine, tangent, and then cosecant, secant, and cotangent. All right, so we should have 7 columns, and then I'm going to have 5 things going down. So this is going to be 0 degrees, 30, 45, 60, and 90. Okay, so I'll even put the degree symbol here. It's good to put units in here. Okay? All right, so sine of 0. Actually, the first row here, everyone should know, and the last row, everybody should know, because that's just from the last chapter, 0 degrees and 90 degrees. So sine of 0 degrees, you guys should all put 0 down there. Sine of 30. Now we're going to use SOHCAHTOA, so it's not bad things. SOHCAHTOA, right? Not bad to have it out here. Sine of 30, we'll go to the 30 degree triangle here. It's opposite over hypotenuse, so 1 over 2. Sine of 45, we go with 45, so opposite over hypotenuse. So it's 1 over root 2, and I'm just going to rationalize it so we don't mess up our chart. 1 over root 2 rationalizes to root 2 over 2. Okay, root 2 over 2. It's kind of messy. Let me get it a little bit cleaner. Oh, there you go. Move this down now. Okay, so let's try it again. Root 2 over 2. Okay, 60 degrees, again, it's going to be opposite over hypotenuse, so root 3 over 2. And of course, we all know sine of 90 is 1. Okay, so that's our first column. Now here's the deal, math fans. You're going to eventually have to memorize these. Okay, I know we're drawing triangles out, and we're coming up with the triangles, and then using SOHCAHTOA and come up with this. But eventually, I'm going to say to you, what's sine of 30? And you're going to go 1/2. You're going to be fast with it, because if you're not fast with it, then you're not going to get done with all the problems. That's just what it is. Okay, so you've got to be good with this, and you've got to memorize this. Now, how is a good way to memorize this? Just working our way down here. I want to show you a pattern. So you start out with 0. So 0 is square root of 0 over 2. Watch this. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Look at that pattern. That's an awesome pattern. You certainly don't say square root of 0 over 2 or square root of 1 over 2, but it at least helps you with a pattern going from 0 to 1/2 to root 2 over 2. So square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Okay? So that's just kind of a nice pattern. And not that we're going to get into it until chapter 4, but the way sine looks, sine starts at 0. You have to know that sine starts at 0, and it goes up to, we're only doing this part today, it goes up to 1, but it starts at 0. You've got to know sine starts at 0. That's really, really important. It goes to 0, and then it goes up. 0, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2, or 1. Okay? Okay, so the rest of this is, again, just using SOHCAHTOA, and I'm not going to, just to make this go a little faster, because truly you can just pull this off of the chart here. Okay, but cosine starts at 1, and it's going to go 1, and it's going to go root 3 over 2, root 2 over 2, 1/2, and 0. So it's actually going in reverse of what sine did. But remember, what do you know about sine and cosine? Aren't they cofunctions? So check it out. Let's look at sine of 30. Sine of 30 is 1/2. What's cosine of 60? Better be 1/2, because they're cofunctions, and it is. Okay, so sine of 30 and cosine of 60 are the same. And how about 45 degrees? Notice that they're both the same, root 2 over 2 for both of them, because 45 and 45 is 90. Okay, so just to kind of help you out with a little bit, but it goes backwards. It starts, cosine actually starts at 1. It goes down from there. It goes from 1 down to 0, and there it is, 1 down to 0. Now tangent this is how tangent goes. Tangent of 0, 0, which we all know that. Tangent of 30, remember, tangent is opposite over adjacent, so opposite 1 over root 3. We say that is root 3 over 3. Okay? Tangent of 45, opposite over adjacent, so it's 1 over 1, which is just 1. And tangent of 60, opposite over adjacent, which is just root 3. And you know tangent of 90 is undefined. Okay? I'm going to get to a good way to memorize some of these for tangent, because cosine and sine you kind of just have to know. You really just got to memorize some of these. Okay, but tangent I'm going to get to it in a little bit. Cosecant. Well, what I can do is, again, I don't memorize cosecant is, hypotenuse over opposite. I just don't do that. I don't have enough brain cells in my brain to put all that stuff in there. I memorize patterns, and I say, oh, well, cosecant goes with sine. So, of course, what's the reciprocal of 0? It's undefined, right? That's the way I remember it. And then, of course, you can just do, once you know sine is 1/2, so the reciprocal is 2. If I flip 2 over root 2 and rationalize it, I just get root 2. If I flip 2 over root 3, I get 2 root 3 over 3. And if I flip 1, I get 1. So that's how I remember that. All right. Well, secant of 0 is 1, right? Because that's flipping over cosine. All right. And remember what I told you guys? Just kind of a little clever way. Aren't cosecant and secant, aren't they cofunctions? So that means the cosecant of 30 degrees, the secant of 30 degrees is the same as the cosecant of what? 60. And sure enough it is. It's 2 root 3 over 3. Okay? And then, of course, 45, it's the exact same thing. And then this is going to be 2. And this is going to be undefined. Okay? And cotangent is kind of the same thing. Reciprocal is going to be undefined. The cotangent of 30 is the same thing as tangent of 60. So that means this must be root 3. Okay, and then if I flip 1 over, so I can do 2 different ways right with that. I can flip it over because the reciprocal of 1 is 1, and the cofunction of 45, they have to be the same as well. So this is also 1. And this one's going to be root 3 over 3. And this one's going to be 0. All right? That is a really, really important chart, math fans. Super important. You want to put like 18,000 stars around this chart. Now, do you memorize it? No. You'd be crazy if you try to memorize the entire thing. I personally would memorize this and this. Okay? You don't even have to memorize all of those necessarily, because you just know that sine starts at 0, and you either have 1/2 root 2 over 2 or root 3 over 2. And then go the other way with cosine. We start at 1, you go root 3 over 2, root 2 over 2, 1/2. Okay, so and here, I got a clever way to help you memorize tangent. You definitely have to know. Personally, I think tangent of 45 is the best, because if I said tangent of 45 or cotangent of 45, it's 1. It's really, really nice. A 45-degree angle, it's going to be 1. Super, super convenient. Okay, but here's one that's maybe a little bit more challenging to memorize. Tangent of 30 is root 3 over 3. The way I look at it is it's a 3-party. Okay, notice the 3-party. So tangent of 30 is root 3 over 3. There's so many 3's there, guys. So tangent of 30, it's a 3-party. So that's just root 3 over 3. It's just a great way to do it. Okay, and then tangent of 60, there's no 3-party. Oh, it's so sad. Just 1 3. Oh, poor guy. Okay, so woo woo woo. Tangent of 30, 3-party. Ooh, I'm doing the sprinkler right now, but you don't see me. Okay, and then tangent of 60 is no 3-party. It's just root 3. And just know also tangent of 45 is 1. And that again will help you with this column here too, the cotangent, because you just take the reciprocal of it. That's all you do. You take the reciprocal of it. So if I said, hey, what's the cotangent of 30 degrees? You'd go, cotangent of 30 degrees is the same thing as tangent of well, let's do the tangent of 30. Tangent of 30 is a 3-party, root 3 over 3. What's the reciprocal of root 3 over 3? Just root 3. And there we go, just root 3. Okay, so again, look for those patterns, but you definitely, I would know these 3 now. I didn't mark this one, but you definitely know those 3. I gave you a couple ways to remember them, but I would know those 3 because if I ask you secant, cosecant, or cotangent, you should be able to kind of pull all that together from sine, cosine, tangent because you're just taking the reciprocal. Okay, really, really, really important. So that's it, man. That's the lesson. And again, this is trig functions of acute angles. And again, I should be able to ask you after today, I should ask you anything with sine, cosine, tangent, any of the trig functions, 6 trig functions of anything with 0, 30, 45, 60, 90, truly 180, and 270, 360. I should be able to ask you any of that. You guys should be able to come up with an answer, okay, without having to draw the triangle. Maybe initially you do the triangle, but after a while, not. Okay? That's it, math fans. Have an outstanding day. Adios. Goodbye.